This will be part one of the Hollow Penny Lab. So I'm going to go right to we have the Hollow Penny Lab, and our goal is to explore the stoichiometric or moultering relationships between the zinc interior of a penny when it reacts with hydrochloric acid in a single displacement reaction. Well, that seems like a lot. Let's stop the share here and let's just take a look at what we have going on here. So I'm going to kind of scroll this down, and I have a couple pennies right here. So you can see these. A couple more pennies right here. You can see these. Now there is a difference in these pennies, and I think you can see this. As I blow on these, nothing happens. How about these? Whoa, that one blew all the way across the table. Nothing here. But these things will get moved around. Okay, so the deal with these pennies right here is they look the same on the outside. It's a copper core, but the whole zinc interior is gone. Essentially, I reacted it with hydrochloric acid, making it disappear. So we just have a shell of this penny, okay, left over. Where these are the full pennies, and I don't have enough hot air to blow that across the table. So how did I make these pennies? That's what we're doing in this lab. I take a file like this, and I kind of find a mark and I start etching it in and try to get some deep indentations. And I will usually get like 4 or 5. And I'm going to just kind of scuff and scuff and scuff and scuff. And I'm going to expose this. I don't know if you can see this here. Trying to get up to the camera and do this correctly. You can see like that gray or that silvery thing. That's where I've exposed the zinc. And so what'll happen is the copper protects it. It won't react with the hydrochloric acid, but the zinc will. And I do 4 or 5 marks like that. So it should be able to have the hydrochloric acid go in there, eat out all the zinc, and then still be left with an intact penny shell without the zinc inside of it. So that's the goal when I'm doing this. All right, I think I'm going to go back to my screen share here and just do a couple things, and then we'll go back and kind of watch what's happening. So I'm going to go back here, go to this share, and it says to scuff it. So I've done that. Record the year of your penny and record the mass of my penny. Okay, so I have a 1998 right here that I'm going to use. And really the importance, as long as you have a penny after 1982, it should have the zinc core and the copper shell. Okay, before that, they were just all copper. So this experiment won't work with them, but other experiments will. All right, I should be able to write on here, and I'm going to write my mass. They're the year of my penny. So in this one, I'm going to put a 1998, and then the mass of the penny before reaction. So I weighed that on a balance right before, and it was 2.50 grams. Okay, the pennies before 1982 weigh about 3 grams. They're the all copper ones, copper being more dense than the zinc inside. Now, we don't know the mass of the penny after the reaction. We think it's going to be less because some of the zinc is going to go away. In fact, a lot of the zinc will go away. And so that's something we're going to figure out in our next day of this experiment. And then we can figure out the mass of the zinc removed and ultimately the percent composition of both the copper and the zinc in this reaction. Okay, I'm just going to maybe go back to this next part. And it says, place the penny in a 250 milliliter beaker, add 15 milliliters of 6 molar hydrochloric acid for each penny. And really the reason I have you put the year on there is just so you don't get them mixed up with other ones in the container. So that's what I'm going to do. And then we're going to leave it go for 24 hours, actually probably a little bit longer, but you can see this reaction on the day 2 part. So I'm going to go back to, I'm going to stop the share. We can look here. You can see on my lab bench, I think I have a beaker. Put some safety glasses on, get some 6M hydrochloric acid. 6M means 6 moles per liter. That's quite concentrated. Okay, so 1 molar is moderate, 1 mole per liter is moderately concentrated. This is 6 times that amount. So this is pretty strong stuff. And what I'm going to do is take my pennies that I have here, and I'm going to drop them in the hydrochloric acid right here. And I'll probably end up covering it with a watch glass, but you might be able to see this. It's starting to fizz up. So these are the pennies that aren't hollow, but I'm going to try to hollow them out. And you can start to see bubbles coming up from, especially the interior, from those spots where those gaps are. A few bubbles are forming on there, and that's coming up. I can bring that closer and help you see that. But we get a little, holy effervescence, Batman. Look at the bubbles. Okay, and my guess is there's a gas, and I think it's going to be hydrogen gas, as you're going to see when you do this reaction. So this is the part where it's bubbling, and I just let that sit for 24 hours, and we're going to kind of see what happens, and then come back the next day. All right, now I'm going to just do a little bit more with you, because even though you can't do a lot of this worksheet, you can get some things started on this first day. So let's do that. And then the second day of the experiment, you can continue with the other parts. So observations, you can probably talk about the bubbling you saw. You really can't do anything else. We had the year of the penny and the mass of the penny, and that's all you can do for this page. Okay, going to the next page, write a balanced equation. Zinc, yes, hydrochloric acid, or HCl. You know what that is. Zinc chloride, you might have to look at your common ion chart to get the right formula for that. And then hydrogen is the gas produced. Remember the Brinkelhoff, the hydrogen travels in pairs. So you should be able to write a balanced equation for this. Okay, and yes, what's happening here, you have a single thing, you have a compound. It looks like the zinc is coming in here and kicking out the hydrogen from this. And I think that might give a little bit of help with number 2 type of reaction in what's being displaced, what's doing the replacing. Okay, as far as these other questions, 3, 4, 5, 6, 7, you can't do those until we get our data with that the next day. However, the last page is a hypothetical page. Just threw a little mole train in there where you're given 32 grams of zinc and you have 80 moles of hydrochloric acid. So here's some sample data from not even this experiment, but from another experiment with the same equation. Balance your equation. And I would do an icebox because you have an excess limiting reactant. You're given amounts of 2 things. What's the limiting reactant? And then you have some other questions you have here. What reactants in excess? How many moles are left over? Moles of hydrogen produced, mass of hydrogen. So that gives you a little practice at that. One hint is this is already in moles, but this is in grams, so you'll need to convert that to moles. Then you can do an icebox, which operates in moles for this, and see if you can solve this page here. So there are some parts you can do. I would work on that, and then we'll finish our data on the second video or the second day, and then you can complete the lab. Just a couple other things. Oh, there is a periodic table attached here, and there is a common ion chart to look up things like zinc and chloride and those things too. So I think that will help. All right, good luck with this, starting this, and we will work with these in class next week or during the first week of quarter 4. Thank you.